recorder.
What are you a professor?
Yes.
We're living on a disk, floating through space, with a tiny sun.
Hey, I'm FTFE, welcome back to the channel that does to stupidity what Disney have done to Star Wars. Today, oh my mic's peaking a bit, I'll just turn that down one sec. There we go. Today we are going to have another debate about the shape of the world, but I'm not debating. We have two awesome people that are going to have hopefully a nice cordial discussion that won't devolve into a screaming match like a lot of these seem to do. So let's just get into it and introduce them. On the side of the globe is Professor Phil Bell. Phil, how you doing? Welcome back to the channel.
Very well, thank you. And thanks very much. And hello to the viewers. I presume they've lined up already?
Yes, we have a few hundred already waiting to see this exciting intellectual discussion, shall we say. Phil, why don't you just take a minute, tell us a little bit about yourself. What is it that you do?
Okay, well, I teach physics, so that's my main thing, but I also delve into chemistry. I actually started my career as a chemist, as an analytical chemist, and I was involved in explosives right at the beginning. And then eventually moved into geophysics, and then now I teach physics, and I've obviously worked at ISRO as well, so I've done some contracting work from them. And now I'm pretty much retired. So,
so you were involved in putting something on the moon, weren't you?
Well, I was in the team that that put the Chandrayaan 2 lander on the moon. Yes, so. Unfortunately, that didn't work out too well. But,
well, it definitely got there. I mean, it's a hard landing, I think is how it's described, right?
Yeah, a splat.
Yes, which is cool. You were involved in a project that actually put something on our moon, which is pretty awesome.
Yeah. Well, I mean, there's more to come. So
yeah,
there's a big race on now to actually get people on the moon and
yeah,
permanent stations. So
it's an exciting time. It really is an exciting time. So. Just tell us briefly what you think of the flat Earth thing in general.
Oh, look, to be honest, it's entertainment. That's it in a nutshell. And you know, I mean, for some of the players, like let's say Nathan Oakley and people like them, it's a product. You know, it doesn't have to be true. It's, you know, it's a product. People are interested in it. They pay to watch stuff, so you know it's a product for all of us, really.
That's definitely fun, yeah.
It's an entertainment product.
Yeah.
And
all right, Phil.
You don't have to be serious about it.
No. Well, thank you for taking the time to join us. I know it's quite early over there, so let's have a word with Wendell. Wendell, thank you for coming back. How you doing?
Hey, how y'all doing today?
Appreciate you taking the time to come and have a chat with Professor Phil Bell here. So, for people who haven't seen you, why don't you just take a couple of minutes and tell us who you are and what it is you do?
All right, I'm Wendell Varner. I'm definitely not a professor of physics. I own a restaurant down here in Charleston, South Carolina, and I'm just a science nerd. So, like I said, for me, it's entertainment, and it'll be a great debate. I think I got some issues that, you know, anybody can see that can side with me on. I got a couple of issues that I think most people can side with me on if they don't have a PhD.
Okay. So What you heard about what Phil's done? He was involved in a team that put something on the moon. What would you say is your biggest achievement that you've had in your life?
Oh man, I'm not going owning my business, man, and raising my
That is
family.
pretty good.
And
Yeah, you've
yeah,
spoken
yeah,
to me about
yeah.
your restaurant before. It
Definitely
sounds quite
not.
good.
Yeah, definitely not putting people on the moon. Definitely
All
not
right.
putting people on the moon. But I will say, I think, for most people, it's all about the dedication and the drive. So obviously, Professor Bell had enough drive to make it through the rigorous training and the schooling that it took to get there. Me personally wasn't willing to sacrifice what he obviously sacrificed to get there. Anybody can achieve these type of things is not that phenomenal. It's all
Yeah.
about what you're dedicated and what you're driven to do.
Okay. Awesome. So, why is it that you think the Earth is flat? Just briefly.
I think from a relative from a perspective of relativity, the Earth is flat. So even if we go from y'all model, if we use y'all model, and we say that the Earth is a sphere, from our size, we would never see it as such. And then when we break it down and we get into things like the geodesic curves and these orbits that actually go in straight lines, and we get into the gravity, we go all the way back into the Big Bang, and that's where I like to start at with the standard model of particle physics, and the fact that gravity is not really useful in particle physics. And I know, when we spoke the last time, you said, well, it's because everything's so small that the measurement would be so small and whatnot, but that's not true. Right now in 2022, we still haven't found a force carrier for gravity. We still haven't found a gravitron. So I think there's a big misconception with a lot of people when we talk about what gravity is. Gravity is a big debate. And for me, gravity is just a container. It is space-time itself. So it is the container that holds us. It is naturally flat. It's only curved by mass. So this mass curves space-time. But it has no force carrier. So it's not a force. It's not a fundamental force, in my opinion. And I think we're getting to the point in 2022 where particle physics is starting to break down, just like Newtonian physics breaks down. It's not perfect.
Okay.
Okay.
That's
Can I take
interesting.
it from you?
Let's go straight into it. That sounds like a good point. I apologise.
Okay, good.
Apparently, my mic sounds dodgy. I'll try to sort that out whilst the gentlemen are talking. But basically, it's over to them. Any questions? We'll try to get to at the end. Super chats, obviously, welcome. We'll get read first. Thank you, everyone, for watching, and please enjoy this conversation. Over to you guys.
Yeah, thank you very much. So Wendell, I heard what you said about you went through quite a few things when you described why you became a flat earther. I mean, but because you certainly wouldn't have learnt that at school. So tell me, at some stage a penny would have dropped, and you would have said, "God damn it, the Earth is flat." So what do you think that is?
I had a debate with a coworker probably about 6 or 7 years ago. And
Yeah.
he's a pretty intelligent guy, and he was making fun of his aunt, who was a flat earther. And I
Okay.
looked at some of the points that she made, and I said, dude, some of the stuff she's saying is absolutely correct, whether you want
Yeah.
to adhere to it or not. So I mean, something like a boat going over the horizon, we definitely can pull that back up into view. Even if the Earth is a sphere, so even if we use your model, it's not big. We're not big enough to see the curve. So it's something that if we're going to use the equivalence principle, and we're going to use the experience of the observer, when we go on an airplane, it flies straight, even though it may be flying a geodesic. So like I explained to Craig the last time, the only way that I can describe the pseudo force of gravity is using the geodesic. So if I put me and you on the same line of longitude, and we both walk to 1,000 miles apart, and we both walk
Come to the
towards
same
the North
point.
Pole, we come to the same point. It pulls us together. So
Yeah.
that's that pseudo force. There's actually no force pulling us together
Yeah.
there.
It doesn't actually matter though, does it? These things will still accelerate towards the ground when you drop them. Do you agree?
Of course. Well,
Okay.
I agree and I disagree, because there's a relativistic answer to that as well. Some people will debate that the ground accelerates up into you. I would debate that we are following the natural flow of space-time. All right.
No,
And what is
yeah.
and what is
Let me
stopping
interrupt you
us
for a
from
second.
that flow is the ground. So what's
Yeah.
stopping us from traveling down our natural flow of space-time is the ground. We don't feel our weight if we're in free fall until we hit the ground. So
Right.
we need to make a distinction for your viewers between gravitational mass and inertial mass, because I think most of your viewers still think that gravity is a force and they're living in Newtonian physics.
Okay. Let me just clarify this once and for all, and hopefully for a lot of the viewers as well. Okay. So general relativity is a model. Okay. There's nothing that says that this is absolute truth. We may very well find out that there's actually a better way to describe gravity. So this is a model. So is Newtonian gravity. But this Newtonian physics has an additional thing that GR doesn't have. It's a law. You know what that means? That it's a law.
Oh, definitely.
But you just dissed on Newtonian physics. But you forget
this on the guy. I love Newton.
Do you understand what it means by it's a law?
Oh, definitely. I understand it.
It means that it happens every single time. It's empirical. Right. In other words, if I drop something, and if I have to discount the if I can discount other forces like wind and air resistance, then it will fall to the ground. It will accelerate towards the ground. And not only that, two objects side by side will accelerate towards each other. Now, it doesn't actually matter whether you or I have some vague idea about why that actually happens. That's kind of irrelevant. It's irrelevant when you get to use it. For example, if I can see that you're alluding to relative density as your explanation for why things accelerate, and we can talk about that. But I'd like you to think about this. If I throw something, or let's say, for instance, I have a gun or something that lets off a ballistic, I can actually predict a number of things from this. I can predict how far it will go, assuming that I know what velocity that it leaves the gun, or whatever the mechanism is. For instance, it could be a rocket. I can predict how far it'll go. I can predict how long it will stay in the air. I'd like to see you predict that with density.
You cannot. You cannot.
Exactly. So why is your default? Why is your default relative density when I've just given you something that is just, squillions of miles away from what you have, which is you've got no way to predict any of those. I can predict these things. Why can't your default be what I suggest?
Well, I don't have a default, and that's the difference. I'm
but
very
you do.
mutable.
You just said rest. You
no,
do.
I agree with you that relative density does play a part when we're going to talk about math and physics. But in every debate that I've had about flat Earth, you can ask Fight the Flat Earth. I've never brought up relative density, bro. I've never, because I know that that's a base argument for flat earthers against you guys. I don't discredit Isaac Newton. His laws of motion are awesome. So I'm not trying to tell you that force doesn't equal mass times acceleration. I'm not debating that fact. We're not going to sit there and debate those maths. And the guy was great for coming up with those concepts. We use them every day. Like you said, trying to get a rocket to the moon, so on and so forth. But there's certain inconsistencies that happens with Newtonian physics. Just like everything else, we evolve. So science evolves as well. And right now we understand that Newtonian physics falls apart in certain instances. So if you're building a house from the ground up and you get to the end and you realize that it's a little crooked, some people just patch it up and say, hey, we're going to fix this. Some people start from scratch and build it right. We know that the structure on which Newtonian physics is built on has flaws. It's not perfect. just like general relativity. So I'm not a proponent for any of them. I'm saying both of the guys are geniuses.
Okay, they certainly are. And I can tell you something. Whoever proposed that density had anything to do with the acceleration is certainly not a genius.
Well, like I said, I never said density had anything to do with acceleration. Your mass has something to do with acceleration. And the problem is when we look at this equation, when we look at Newton's equation for why things fall to the ground at the same rate, we have to take into account that gravitational mass in this instance is the same. Well, according to Einstein, gravitational mass in this instance is exactly the same as inertial mass. So they cancel each other out. Therefore, the object that's falling doesn't have a mass to calculate, because the inertial mass on one side and the gravitational mass on the other side cancel each other out. So that's what we should be explaining, that at the point of free fall, things all weigh the same, and we shouldn't say weigh the same. We can say weigh the same. You know, you understand exactly what I'm saying.
Yeah. Okay. So like I said, let's forget about that. Let's concentrate on the things that you and I can measure. Okay. Right. So we can speculate all day about why gravity happens. I'm interested to know why you think the Earth is flat, because I mean that contradicts just about everything you can think of in physics. That's a pretty deep thing to say, that you think the Earth is flat. I mean, that is
well physically I had to agree. I had to agree with the physical observation of people who were making this claim. So when I look out and see the clouds, you know, going further and further away from me, I know that these clouds are not drifting off into outer space. All right, they're following a straight path, whether it's on your sphere or whether it's on my flat plane, it's following a straight path. And I think most of the globe people who, you know, are fighting against the flat Earth don't understand that even if the Earth is a globe, we would see those clouds moving in a straight line called the geodesic. We would not see the distortion of these clouds as they get further away.
No, not at all. You'd see them going around a sphere, which is exactly what you see. I suggest that you've probably never really looked at this in detail. The next time you see a cloudy day, you know, where you've got patchy clouds, have a look at those clouds as they approach the horizon. They definitely go around the horizon. They definitely do that. They do not keep going in a straight line so that they get smaller and smaller until you can't see them any further. They do not do that. They go around the horizon. Why don't you have a look at that? You'll see that. You'll see that for a fact. And now that's the same with the sun. That's the same with boats. Now you mentioned earlier on that boats that you can pull the boat. You can see the boat again if you have a strong enough telescope or a strong enough camera. Is that right?
Definitely.
Would you mind if I showed you something? Because let's
agree
on one thing.
All right.
You wouldn't agree. You would discount anything that was absurd, wouldn't you? That was even to you.
Oh, of course.
Okay, let me show you something. I presume Craig's going to let us share stuff. All right.
Yeah, you should be able to screen share.
All right, just give us a minute till I find this. Well, I thought I had this prepared, but there you go.
That's okay. Take your time. So say thank you to everyone in the chat for being here. Awesome to see so many coming to see this discussion. Thanks for the super chats, guys. Really appreciate it. We'll get to all your questions at the end.
Okay, so I'm just going to share this with you, and then we'll talk about this for a little while, okay? All right. Okay. Can you see the screen?
Yep, definitely.
Okay, what do you see?
I see, what is that, a windmill? A big ship?
That's a big ship. Should we be worried about the children?
Okay. All right. I mean, yeah, that's a very awesome picture. You know.
I, you've edited
So
now. Now
like I
let
said,
me just lead this, Wendell. Just let
uh,
me lead this for a little bit, okay? And then I'll
yep,
give you a chance, okay?
yep.
So clearly, we're not going to be worrying about the children. This ship is not sinking. It's happily going along, taking its people on a cruise. Now, Wendell, what lens, what camera can you think of that we could use from this point on? Because I mean, this is obviously zoomed in about as max as you can get. Actually, zoomed in probably with one of your favorite cameras, you know, those P900s. So this is zoomed in as far as it'll go, and we can see that the chimney, the stack of that ship very, very well, quite clearly, considering how far away it is. Can you think about any telescope that we could use that could bring this back so we can see the whole ship again, or do you think that's absurd?
I think that's absurd.
Okay, can you please stop saying from here on now that you can bring back a boat with a camera? Would you please stop saying that? Do
No,
you
I
agree with
won't.
me? Do you agree with
No,
me?
I agree with you that they make. Cause see, you didn't give me a chance. So see, like I
Okay, now
said,
you've got your chance, because you
right.
can tell me,
So
because
so
you can
like I
see it's
said,
absurd. Yeah.
so yeah, definitely this picture right here would definitely make proof of your point. All right.
Good.
But what
Yep.
I'm telling you is I seen flat Earth pictures, and I don't know how to screen share. I'm not even gonna get into all of that because that's not part of the argument for me. So according to your picture, yes, this makes a point for your argument. I'm not ashamed to say that, but I do know there's things that can cause us to see things in a different light. So I've seen mirages where it looks like the boat is floating in thin air. You know, so I mean, there's different ways that the atmosphere refracts, especially over those bodies of water, depending on how hot the day is, whatever else you got going on. So that would be my only argument against your picture. Other than that, I would have absolutely no problem saying, hey, the Earth is a globe. But there's some things that I'm going to explain to you that a flat earther can also say. I can tell you just like this. I can walk level, directly level, and keep my height. Let's just say I can walk on air, and I can walk 3 inches off the ground, and I walk straight towards that boat, and I maintain my straight level line. My body, I will not observe a curve. All right, I will
You
walk
will.
straight to that boat, and I would not observe a curve. So at what point does that boat come back in full view? I can't answer that because I don't know what kind of atmospheric, refraction or what else is going on in that picture. I seen a picture of the Chicago skyline from 60 miles away the other day on Facebook, and the guy said it was a mirage. So hey, it could be. So as well as that, it is what it is.
Do you
I
think
can't
it's a mirage?
I can't deny. I have no clue. I think that if I walk in a straight line towards Chicago, that I would get to Chicago, and that I don't have to account for any curve.
I know you like to think that, but that doesn't make it true. I want you to focus on this because I want you to leave here. You've already agreed that it's absurd, the idea that you could bring this back with a camera, because I hear this a lot. I want it dead once and for all. I want that removed from the lexicon of flat Earth once and for all. There is no way, no, there is no chance that you can have any camera, no matter how big the lens is, that you will make this boat come back. Let's accept that. The idea that you could do that is absurd. And now you told me you would not believe anything that's absurd.
Oh, definitely wouldn't.
Right.
And so I'm not part of any organization, whether it be a Christian, Muslim, Jew, flat earther, globe earther, any of that. I'm in this straight for the science and for what I feel is right and wrong. And I have to agree with the flat earthers on a lot of their, I don't agree with them on everything that they say, but I know that I've seen pictures. I think they call it the black swan picture or something like that.
We'll get to that. We'll get to that black swan. Don't worry. But do you agree with this though? Don't you? Yeah.
I agree with that.
You agree that it's now the idea that you could bring back anything something that's gone beyond the horizon, like this boat has, you agree that it's that notion is absurd, and
In
you
that
don't
instance.
believe, and you certainly don't believe things that are patently absurd, right? Okay,
Right.
so let's move
In
on.
that
All right.
instance. Right.
Okay, that's all right. Let's move on. Hopefully, this is not in your lexicon anymore. Okay. All right. Okay. Let's carry on. Okay. Now,
right.
just in the same vein. All right. Just so that you know that it's not the only instance of that sort of thing. Let's have a look at. Let's have a look. What have we got here?
How could you prove that Chicago skyline was a mirage?
Oh, that's pretty simple. I just want to let's have a look at this one, and okay. I just want to
Show me let's see the Chicago skyline. Let's see something on the flat Earth.
Yeah.
Well, let's see.
I
Don't pick them all now. Don't punch me in the face. Yeah, show a picture of the Chicago skyline and explain to all your viewers mathematically what's happening.
Okay. Well, yes, I certainly can do that. All right. I'll tell you what. I'll show you this first, and then we'll do that. Okay. All right. Because that's a reasonable question. Okay. So have a look at this one. Can you see that?
Yes.
Now? You see the waves are quite small, so we can't say that this is large swells that are blocking that, can we?
No, sir.
Okay. There's no camera that's going to bring this back to in its quality. That let's have a look at.
It's a mirage, man.
Yeah, that's not a mirage. if that was a mirage, if that was a mirage, I would see
what
all
were
of
the
it.
things to the? But on a serious note, what were those things to the left of it? Pull that picture back up for me, please, if you can.
Sure. Where is it now? There we go. Excuse me for this. There's quite a lot of steps involved in sharing.
Yeah, definitely. All right, so over to the far left, what's those buildings?
There are obviously some other structures that are blocked by the water, aren't they?
Right. What's the
By the
distance from the viewer to the to that structure, and what's the height of the camera?
This looks like the camera is pretty low to the water.
Exactly. And if
however,
that's the case, then
yeah, that makes it worse for you, not better. So this looks like it's reasonably low to the water, and it looks like a day of, minimal refraction, if you like, probably taken on later on in the day. Actually, just looking by the shadows, I don't know, it was either a morning or 3 o'clock in the afternoon, something like that, and you can see. You can see that all of these structures out there are actually blocked by the water, and you can see that from the ripples on the water that this water is not very rough. So it's clearly this is blocked by the horizon.
Look here, I get that, and just bear with me. Yeah, this might be one of your guys' Flerf moments, but I get that the degrees that the Earth would change, that it would curve out, would be 1 degree for every 69 miles, I think it is, something of the sort, 60 some odd miles.
Mm-hmm.
But if this much water is covering that much of a building, then that building should be curved off as well, regardless if it's 1 degree or if it's a half a degree. If it's that much, that's why I asked you, what's the height of the building, because whether the Earth is curved or flat, there's a discrepancy with what you're saying, because that building should be leaning away from me at that point. If there's that much of a curve between me and that building, it should not be, whether the Earth is a globe or a sphere, there should not be that much curvature between me and that building. That's what I'm saying.
So this distance to that horizon would be approximately 3 miles. Okay.
Exactly. There should not be that much curvature in 3 miles.
So how much?
It's not.
So do you think that if something was leaning back, just for the sake of it, we'll call it that, over 3 miles, how far would it lean back? Do you think?
If
How
that's
would you
not
how
that
would you notice that from here?
that's not what I'm saying. What I'm saying, the same way that I would notice that much water covering that much of a building. More than half of that building seems to be covered by water. All right. So that would mean that we would be experiencing that much curvature between you and a 3 mile distance, when we know that we don't experience that much curvature in a 3 mile distance, even if we use your math. So if we use the structure that y'all have, that y'all agree with, that building should not be obscured. And I can show you pictures of boots that's smaller than that, that's farther than 3 miles out. So to say that at this instance, at 3 miles out, half the building is covered, why is it that I can see a little tiny sailboat at 10 miles out?
Okay, well, I mean, that depends on the time of day, the atmospheric conditions of the day. There's a whole bunch
exactly.
of
So what you're doing is what they call like gaslighting, all right? Because what you're doing is showing a picture. Well, what you're doing is you're showing a picture that's not true. It's not consistent with everything.
What do you mean it's not true?
It's not because
you think the camera lies?
So what happens in the same instance when we see a boat that's 10 miles out that we can still bring back into view with the camera or whatever you guys using to film these things? What's the difference then? There should be a definite mathematical equation to say how far. But here's the thing. Just like the flat earthers always got their little electromagnetism go to special density they go to, you guys always got you go to too, and that's called light refraction. So if I can see something out the distance that I'm not supposed to see, then you guys say, hey, light refraction.
Of course.
But I'm very neutral, just like the
No, you're not neutral. Don't pretend you're neutral. You're not, because I've shown you two things that are absurd, and you still didn't connect you.
Because they're
a normal person would have said, "You got me right there."
So what about the picture where I see the boat 10 miles out, and this picture is 3 miles?
The only way you're going to see a boat 10 miles up is if you're high enough.
No, there's people who film structures from, and maybe not 10 miles. Let's just say 3 miles in equivalence to this the structure right here. We can say 3 miles. I've seen
the kind of picture you're talking about where the flat earthers have they zoom out and then they zoom in on a ship that's right on the horizon. And they zoom out and they say, see, we can bring back a boat that's on the horizon. You started this conversation by saying you could bring back stuff on with a lens. You started this with that very phrase. I have shown you that that's not right and that it's absurd.
You have shown me that is not right in every instance. You have not shown me that. Because you can't explain
I only needed to show you one, and you agreed that it was absurd.
So is it absurd that we see anything that's smaller than that structure, that's half the size of that structure, beyond 3 miles? Wouldn't you say that that's absurd?
No.
Why not?
Because
you can't have your cake and eat it too, brother.
Because there's a couple of things that'll allow you to do this. One is
light refraction.
You could be high enough. And yes, the other one is refraction. You don't like that word refraction, but let's move on.
I love it.
Let's move on to something else.
If I could just quickly clarify, I think Wendell was a little bit confused. Professor Bell isn't saying that building is 3 miles away. He's saying the horizon is 3 miles away.
Correct.
And it's hiding that building, which is further than 3 miles away.
Much further than 3 miles away.
I thought he was talking about the structure.
No. Sorry, I probably should have mentioned that earlier. I think you got confused there. Yeah, he's saying that the visible horizon is going to be roughly 3 miles away because the camera's quite low. So the things that you see in the distance, that building, and to the left, I think that's some cranes, are obviously going to be much, much further than 3 miles.
Probably 5 or 6, maybe 8 miles away.
Yeah.
Gotcha.
So I think that's what he was saying.
Yeah, correct.
Sorry to interrupt there. I just wanted to make
No,
sure.
no,
That
awesome,
was
man. I'm glad you
No,
clarified
that's
that.
okay. I make assumptions along the way that you would know certain things, you know. So
Well,
forgive me.
I mean, I asked specifically what was the distance to the structure. I didn't ask what was the distance to the horizon, but hey, I got
Okay,
you. Simple mistake.
I'm concerned about the horizon, okay, because the
Right.
horizon is what tells us that the Earth is curved, okay.
All right, so anything beyond 3 miles, we shouldn't be able to see. Anything that we would see beyond 3 miles would be absurd. And if we see it, then what we do is we create up reasons why we see it. All right, that still
we
fits
don't
within the
create the
model.
reasons.
We
We're
have
not
to. We're
responsible for
humans.
creating refraction.
We create.
We recognize it, but we don't create it.
So I mean, refraction is very specific to when you need to see something
Okay.
in a straight line at home. So I mean, yeah, that's a reason why some people like me would believe that the Earth is flat, and I don't think that it's too absurd that we would believe that the Earth is flat when
No,
there are some discrepancies, like I say, even
hopefully-
mathematically.
Hopefully, by the time we get to the end of this discussion, you will believe that even that is absurd. Okay. Now, I was looking for. Oh, here it is. This is an awesome picture. I'm just about to show you now. Okay. I know you're really going to enjoy this one. Everybody's seen a lot of this. In fact, probably too much. But I'll put this up, and I'm sure you're going to absolutely enjoy it. You recognize this? Do you recognize
so.
it? Do you recognize this?
I think so.
Yeah, this is what they call that black swan.
It's the black swan. Yeah, got you.
Yeah.
I'm sorry, okay. I lost my damn glasses, but yeah.
You know that those are the same two rigs?
Yep, cool.
Can you please tell me why these photos are different?
Light refraction.
Bingo.
Yeah, it's bending the water upward so it obscures your vision. It would make more sense that way.
Light refraction. So can you please tell your flat Earth friends to stop saying that this black swan means we can see too far?
Like I said, I know you. I know you.
Can you please stop? Can you please tell your friends?
Hey, listen. I don't have flat Earth friends, so I'm actually probably one of the odd bunches out the group. Most of my friends probably don't even waste a minute of their day thinking about whether the Earth is flat.
Okay,
or
no, I'm thinking. I'm talking about your flat Earth.
You're thinking I'm Eric Dubé or whatever the guy is, but I'm not. But in any instance, I do see a picture where I can see more of this rig than the other picture. So what that tells me is atmospheric. That atmospheric. It'll mess it up. It'll obscure your vision. So that I think that it can work in both ways. I can make the argument both ways. So I think that I think that the debate should be more based on a scientific aspect versus us looking at pictures. Because the pictures sometimes don't tell the whole truth. There's a great saying that says the whole is greater than the sum of its parts. We can't debate what's going on in these pictures because a million different things can be going on that we can debate about these two pictures.
If I gave you a lecture on refraction right now, we'd probably bore everybody to death, and you wouldn't know the mathematics that goes with it. So this is why I'm showing it, and I don't mean that to be condescending either.
No, I got you. So that's fine.
It's you like you said in the opening. I sacrificed my life to learn about physics, to learn about chemistry, to learn about mathematics. Okay, so it's not. So I wouldn't expect you, who have sacrificed your life to be in business and things like that, to know the mathematics that I know. So it's not your fault, and it's not something I would expect you to know. So I don't want to bore everybody to death by going into giving you a lecture on refraction. I don't need to. I've shown you here. Now, what I want, whenever I do something, like if I'm in one of my lectures, I want a result at the end of it. Okay? The result I want from this is that whenever you hear a flat earther saying the black swan is is evidence that we see too far, you will correct them.
No,
From
that's not
here
going to happen.
on, from here on, you will correct them and
That's
say,
not going to
no,
happen.
it's not. Yeah,
It's not going to happen. The only thing I'll correct the most things that I correct flat earthers on when I play on a little Facebook page, because that's where most of my flat earth action goes down. The most absurd thing that I hear flat earthers, well, it's a couple of them, but the most absurd thing that I've heard a flat earthers say is Antarctica doesn't exist, or the ISS isn't real. So I mean, if you want to throw those kind of things at me, hey, yeah, fine.
No,
Man.
no.
That's the type of crap that I would tell a flat earther that they absurd for saying. But to tell me that, but if they show me a picture showing something that should not be able to be seen using the Earth's curve calculator, then I would say, hey, I understand why you showing me this picture and why you feel the way you feel. So like I said, the debate for me needs to be more of a technical debate. I don't agree with flat earthers on everything that they say, just like I don't agree with the globe on everything that you say. And I will agree that the earth is a globe mathematically. So mathematically, it works out that the earth is a globe. I'm not going to debate
Wendell,
that fact.
can we just focus, please? All right. I just want this. Let's just focus on this, okay?
On the picture.
I'm all right. I have a million things to do, right? And I've decided to come on today because I wanted to share some knowledge with people and just defray some really, really absurd things. And this is one of them. Now, you will hear flat earthers say that black swan, that what they call that image, the one below, where the rigs appear to be above the water, they will say that is proof, and they'll even use that word, that the earth is flat because you can see too far. Now, you are going to hear that time and time again. You're going to see this image time and time again. They will never show you the one that's above it, though. They will show you this one, and they will make the claim that this says that the earth is flat. That's one of their major things. Now, all I'm asking from you is something very simple. When you hear that, in your mind, you will remember this day. This is a cathartic day in your life, because this day you will remember two things. I showed you that you cannot bring back a boat that's over the horizon with a camera. I showed you that this black swan is you can see it this far away, this far, the horizon, this distance, because of refraction. I showed that to you. There is no way unless you've got some sort of reset switch. When you go to bed, you reset and forget everything that you've heard before. You will not forget this day. You will not forget that I said this to you, that I showed you this. And every time a flat earther says that to you, you will say in your mind, BS. We got that?
No.
All right, let's move on.
Not at all. Right. Let's move on from that right there. If a flat earther shows me that picture, that black swan at the bottom,
you're going to say BS.
I can go grab you and I can say, yeah, man, I got a guy with a PhD
do it yourself.
that can break down the mathematics on why you see this thing and that how it bends it down perfectly to make the earth appear to be flat to you. But hey, like I said, we can't base those type of things off of pictures. And that's a point that I like to make. It needs to be more of a technical argument. So when the things that I agree with flat earthers on is the things when they say like, hey, gravity is not a force. All right, cool. I'm cool with that. Because at the Big Bang, I know in standard model of particle physics, there is no force carrier for gravity. Now, and I'm not saying that we won't ever find one. All of this the Higgs field and all of this research and the research into the origin of matter may push us into the future, may give us a leap and bound. But right now, there is no force carrier for gravity. So when I hear a flat earther say gravity is not a force, I hear globies say, hey, oh man, yeah, you're wrong, man, you're crazy, you didn't graduate elementary school. Well, in actuality, these flat earthers are right. We can debate for years the origin and the source of matter, and the origin and the source of gravity. But one thing we do know is that in 2022, it does not fit into the standard model of particle physics. And I don't think that that's a question that you're prepared to answer. I don't think you're prepared to answer why gravity doesn't have a force carrier if it is a fundamental force.
No, I'm definitely not going to. I'm definitely not going to go there.
Exactly.
As I said, I don't want to bore the listeners, but I want you to think about this, okay? Seeing you on the topic of gravity. Now, let's say, for instance, you're standing there barefoot, and I stand on your foot. Okay, let's say I stand on your foot, and it hurts, right?
Yep.
Okay, all of my 80 kilograms will be standing on your foot. All right.
Right.
Okay, so do you think that you will feel some pain?
Definitely. I definitely feel some
feeling pain. What would you call that action that's on your foot? What would you call that?
What I'm doing is I'm stopping your natural flow.
I'm trying to get you to say, am I exerting a force on your foot?
I feel the force of your weight of your mass on my foot because I'm blocking you, because I am blocking you from your natural path through space-time. Anything that's blocking your natural path through space-time.
I don't want you to describe the model, all right?
That's the only kind of conversation that I can have.
No. I can argue against that model every day. All right. I don't want you to discuss the model. I only want you, Wendell. Please focus on the things that you and I can see. Forget about why gravity happens. Forget about the model. I don't care about space-time. I don't care about that. If I want to look at that model specifically, I will. Mostly in my life, I have to deal with reality. I have to deal with things that are happening in front of me. Now, I said to you, I'm standing on your foot. I'm exerting a force on your foot, right?
Yeah.
Now, okay, Wendell, what about if I jump on your foot?
You're going to exert more force.
Will you feel pain? Will you feel pain?
Yeah.
Why?
Because I'm blocking your path through space-time.
Because I'm exerting a force.
I'm in your way,
right?
I'm stationary. I'm in your way. So it's inertial mass hitting inertial mass. It's your resistance. Inertial mass is your resistance to being moved.
Focus, so Wendell, please. Wendell, focus, please. Focus.
Focus on what?
I've jumped on your foot. Have I exerted a force or not on your foot?
Yeah, you have.
Right. Where did that force come from, Wendell?
From your mass.
And you think just my mass?
From your mass and your acceleration.
Bingo.
Force equals.
You've got something there inside you we can fix.
But see now what it is you have a problem, and I hope you don't teach your kids like this, but you have a problem that you're not willing to listen and kind of see. I understand that everything that you probably teach or the level of physics that you probably teach, I've probably been through that level of physics. But anyway,
I don't think so.
but anyway, force equals mass times acceleration. So regardless, if we take your mass times your acceleration, and I'm going to get the force that's going to be exerted. But the distinction that needs to be made for Wendell is what kind of M was Newton talking about in this equation? Was it gravitational mass or was it inertial mass? Because your resistance to being moved is why it causes pain to me, because you are exerting inertial mass on me, and the resistance to me moving that mass is going to cause my pain. It's a very simplistic understanding of it.
Listen, Wendell, can we?
Am I correct? Am I wrong?
No, you're wrong. Can we forget about? can we just forget about Newton and forget about Einstein? Okay.
Cool.
Let's just Wendell. Let's pretend they never existed.
Let's do it.
Okay.
I like that.
Right.
I like that.
I stood on your foot, and I exerted a force on your foot. Right. Let's call that pain that feeling of weight on your foot. We'll call that force. Okay. Right. And when I jumped on it, you felt that too. But you see, when I jumped on it, I accelerated towards your foot, and you felt a force, didn't you?
Yep.
Yeah. You get the idea now? We don't actually have to go back to Newton's model or Einstein's model and think about this. We can just talk about this, you and I, like this. Just like I said with the ballistic. We fire that ballistic. It's an imperative that I know how far it'll go, because I've got to hit a target. It's imperative that I know how long it'll be in the air, because let's say, for instance, it explodes when it hits the target. I've got to know when it's going to happen. So I've got to know how long it's going to be in the air, and I've got to know when it's going to hit the target. Now, I can do that only because I understand how things fall. In other words, they will accelerate towards the ground. I know that for a fact. Now, Wendell, do you think that of all the 50 years that I've spent as a scientist, it hasn't occurred to me that I wonder why we think the Earth is round? Well, I have. There's many instruments that we use to work out why the Earth is round. And many reasons I can look at and think, well, this is why I would think the Earth is round. Let me go through a few of them with you. Do you mind? And then we can discuss them. All right? And then you can tell me why you think that's wrong.
Nice.
Let's start with an instrument that's well known. It's called a gravimeter. Okay. All right. It's called a gravimeter. So this thing measures the acceleration towards the ground. It's a very, very useful tool because it saves millions and millions of dollars for those people who are looking for minerals. Right? Okay. That's because this thing that we call gravity, mass does attract mass. Okay. In other words, if this instrument is in a region where there's a clump of mass that's bigger than others around it, we will notice it, because that gravimeter will register a bigger acceleration. It will change. So that's one of the reasons that with the gravimeter. Okay, I don't know how density fixes that, but I'll give you a chance to explain how density fixes that. All right, now how explains that. Now the other thing about it is that I also notice when I take this gravimeter around the world that it changes. In fact, I can see a distinct change with latitude. Now, I look at that and I say, well, what can I attribute that to? So I've got latitude, I change the latitude, makes a change in the acceleration. Well, I'm looking at that, I'm thinking, well, I'm pretty sure that if the latitude, if that's a change, then I can attribute that back to the motion of the Earth. Because I do know something about motion, about circular motion. Okay, for instance, acceleration, mv squared over r. Okay, all right. So I know that, and I can use that to make incredibly accurate predictions. So I can see that the reason that this gravimeter changes is because the Earth must be rotating. Have I got another reason for thinking the Earth must be rotating? Not only is the Earth rotating, by the way, let me get back to that one. Not only is the Earth rotating, but the latitude must be getting the circumference at each latitude must be getting smaller and smaller for that to be possible. For the change in speed. So that gravimeter, that little instrument, has shown me two things, Wendell: that the Earth is a sphere, and also that it's spinning, as does Foucault's pendulum. That does the same thing, because it's going to change. The precession of that pendulum is going to change where depending on my latitude. And again, shows me not only that the Earth is a sphere, but shows me that it's also spinning. And Wendell, if that's not enough, Wendell, as a flat earther, any two places along the equator, pick any two places along the equator, they're going to be further apart than any other two places, both north and south of the equator, between the same longitudes. Can you imagine, Wendell, a flat Earth situation where that could happen? Do you think, what do you think that, because it certainly wouldn't look like the AE map, would it?
I don't subscribe to the AE map, brother.
Okay, well, that's a big plus on your account. Okay, now Wendell, I want you to think about this. Okay, and I can show you with a diagram, but I haven't quite got it ready, and perhaps we will during this discussion. So Wendell, you know, one of the beautiful things about mathematics is that you can make calculations about things that are near and things that are far away. Okay, that's a wonderful thing. So I want to talk about the sun for a second. All right? Well, more than a second, but yeah. We'll talk about the sun. So Wendell, when you see the sun at the horizon, okay, it's just about to set, how far do you think the sun is?
I'm not going to make that assumption. I know what flat Earth is saying, and I know what you're saying. So
well,
I know 93 million miles. I know 93 million miles, and I know 3,000 miles. So and I understand why they came up with the 3,000 miles, and I perfectly understand why y'all came up with the 93 million miles. So we don't have to get into the extremities of that.
Well, I just want to point out something to you. Okay, if the Earth was just half a degree off the horizon, so that you could see it. You could see that it's not set. It's not gone beyond the horizon. If it was half a degree, and you're 3,000 miles, okay? So if I do some mental calculations here, at 3,000 miles, so those of you can follow me and just see how this works out with 3,000 miles, I can work out that if I'm looking at the sun a half a degree above the horizon, and it's 3,000 miles high, that's going to be 3,000 divided by the tan of 0.5. Now, just some mental arithmetic, that would be around 343,000 miles away. That's how far the sun would be, Wendell. The sun would have to be 343,000 miles away if you were looking at it just half a degree off the surface on a flat Earth. Is that absurd or not?
I don't subscribe to a distance. Like when you asked me that question, I told you, I don't subscribe to 3,000 miles. I don't subscribe to 93 million miles. I understand why we get the both.
I'm glad you don't. But the next time
I understand why we get both of those calculations, why they came up with this. And I'm going to be perfectly honest with you. I never heard of Eratosthenes until I started going on that flat Earth page. They wasn't, if they taught me about him in school, I didn't remember the guy. He wasn't as big as Socrates or Plato or Pythagoras or any of these guys to me. So what I'm telling you is I don't subscribe to any personal model. What I'm telling you is that there's problems with your model that would lead some people to believe that the Earth is flat. So just like you tried to, you know, I know how we go, but when you said this now, you said, well, if you stepped on my foot with a, you know, with a certain amount of acceleration in your mass, would I feel a force? The answer is yes. But then I can ask that question in the middle of thin air, in the middle of outer space. So if me and you are in the middle of outer space, devoid of any large objects, no gravity, no nothing working on you, and you came crashing into me, whatever your mass is, times your acceleration, I'm still going to feel that force. So that doesn't make a valid argument for your gravity explanation or why I feel pain when you stepped on my foot. Because if I'm in the middle of outer space and we still apply the same thing, the same math, force equals mass times acceleration, I'm going to feel the same amount of pain that I would feel on Earth. And that's what you're failing to explain to your viewers, that there's a difference between inertial mass and gravitational mass. So second, when we talk about the gravitron that you talked about, that measures all of these things, all right, a gravitron definitely, a gravimeter definitely would make a cause for your rotated globe Earth. Cool, I get that. But I do also understand that every instrument that is made has to be calibrated to do what it does. These instruments don't do what they do on their own. We humans program these things to act how we need them to act. So if we set a basis for that gravimeter, then we know how this gravimeter is going to act in certain situations. And definitely it works. You know, like I said, it makes an argument for you, but most of us don't have a gravimeter. So if we go outside and we look, it looks to us that like the stars are moving across the sky. It looks to us like the sun is moving across the sky. I'm not saying that we're right, but no, at least you guys can say, hey, I understand why you say that when you look out of your window. I understand, but hey, this is the math to why Polaris never moved in a million years. This is the math to why the constellations are the same as they were 50,000 years ago. But you should at least be able to understand when a person looks out relative to our reference frame, everything is moving. And it would be impossible for us to tell the difference on if we're moving or if out there is moving if we're in this non-inertial reference frame. We would not be able to see any of this moving. Now, if we were in an inertial reference frame, we would see everything moving, and everything that we would see would be moving in these from the view of the observer. So the apple that falls straight to the ground is going straight to the ground from the view of the apple. From the outside of observers following a curved path. All right. So, like I said, a lot of things that you say can go both ways. And a lot of times, I think a lot of you guys just don't. You make arguments that's totally obsolete, just like that foot argument or the gravimeter argument.
Why is that argument obsolete?
Because it had nothing to do with gravity.
No,
because you was trying to get me to say that the force that was exerted was gravity when it was not. Because if we are in the middle of outer space where there is no mass around us, there's no gravitational.
I was just going to correct you, Wendell. Just stay for a minute. You said that if you were in you said that if you were in space, which, by the way, is a very nice thing that you agree exists. So you're a very unusual flat earther, because most of them say space is fake. But given that you agree that space is that takes a lot of the the wind out of my sail, actually, because I was going to argue with you about space being fake, but never mind. But I want to get back to what you said. You said that you would feel your foot would be hurt if I bumped into you in space. If that happened in space, you wouldn't. Okay. The reason your foot is hurt is because you got the ground also resisting underneath that, and that's why your foot hurts. If I just bumped into you, your foot wouldn't hurt. Okay. So.
Can I correct myself? Can I correct myself? My foot wouldn't hurt.
Hang on, I haven't finished. I haven't finished. I've got another.
Wait, one sec, guys. Prof, just let him correct himself if he was spoken wrong, and then we can get back to your response.
Let me correct myself. My foot may not hurt, but I would feel the exact same amount of force, is what I'm telling you. The force is force equals mass times acceleration. So if we are in the middle of outer space, the laws of physics don't change. It's never going to change. Your force equals the mass times acceleration. The same amount of force that you hit me with, it's going to be the same amount of force. That's the math that we use.
Yeah, and what's the problem with that?
There's no problem with that. What I'm telling you, what your argument that you made would mislead your viewers into thinking that the force that caused my foot to hurt here on Earth is caused by gravity. And that's what you wanted me to say. You tried to force me into say that.
What do you think? What do you think caused it? Caused me to fall towards your foot, to accelerate towards your foot?
I think that you were following your natural path through space-time, and I stopped you. So if we are, so listen again.
Yeah,
If
I'm
we
not
are,
arguing with that. I'm not arguing. I'm not
let me ask
arguing
you a
with that,
question.
Wendell.
Wait, one sec,
so
guys.
let me
Let's
ask you a
not
question.
let's
We
not
call
talk
that
over each
gravity.
other. Hold on. Let's not talk over each other.
Okay.
Professor, please respond to what Wendell said there, and then I do have a question from the audience that I think needs to be asked.
Right,
So, Professor.
Okay, go ahead, Wendell. What do you want to say?
Oh man, I lost my train of thought. Oh, man.
Sorry, there was, right, okay. Let me ask my question because I think this is relevant to the conversation. A lot of the people in the audience are asking, Wendell, could you describe to us the difference between weight and mass?
Yeah, weight is the force that's created by gravity. Mass cannot be changed. Mass is defined as the amount of matter in an object. So mass never changed. The problem with weight and mass is that weight is inconsistent. It changes depending on the gravitational field. Whereas mass is 100% consistent. So if we ask a scientist what are they going to use, or they're going to use to measure something, they're going to use mass. So I mean, like I said, it's not like I have an elementary education. I do understand what mass is. I have a different understanding of why we applied this math and created weight, because in most instances we can use mass and we can get the correct answer. And I know Isaac Newton understand it. And that, to me, that's also a relevant question when I'm debating what is the difference between gravitational mass and inertial mass. You know, to say what is weight versus mass is very, very condescending.
So do you agree, Wendell, that mass is a quantitative measure of a resistance to inertia?
That's what we call, that's what inertial mass is.
Okay. So we're not actually that far away from each other, Wendell, because the only thing that's left really is, because I mean, I see that you've got a reasonable, you know, high school understanding of how this works. Okay, I actually I'm quite impressed, Wendell. So
it's not bad for a flat earther.
I think that you're pretty good.
You guys are awesome, dude.
All right,
sorry.
So I think you're pretty good. and you haven't said something absurd like space is fake. Okay, you realize space is a thing, right? And those objects that are in space, now that we agree that space is fake, is there any reason why you think we can't send a rocket to the moon?
Brother, I'm not going to debate whether there's something like the moon landing. It's just like it's something that's going to be very.
Just sending. Don't worry about the moon landing. Let's just talk.
Well, listen. If it's a common sense question, should require a common sense answer, right? If there's something physically out there that's able to be reached, maybe with the proper technology, you may be able to reach that thing that we're talking about. So I'm not going to deny that there is something. See, something simple, an easy way. If a flat earther say, "Hey, man, those objects out there ain't real," you could easily say, "Well, the energy that's coming from those damn objects are definitely real because we can capture this energy. We know that the energy is coming from somewhere, right?" So to me, that's an argument that's very elementary. We don't need to debate whether outer space is real or not. Now, when we debate whether us humans have been there, and if we are exploring outer space and doing X, Y, Z, that's the argument that we can debate, because I don't know. I'm telling you that in my mind, it would be very, 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 very difficult in order to do this, being that the speeds that everything is moving within the model that we currently use. But hell yeah, there's the moon is out there and the sun is out there and there's stars out there. I see them every night. So there's something that's physical. So anything that we can describe using our five senses, we consider those things to be physical. And if there's physical energy coming from these objects, space is real. So I mean, that's not what we're debating. Yeah, that's not what we're debating, man.
Right. So yeah, we can send a rocket to the moon. So and you can add a few more varies on top of that. Very, very difficult. It is
exactly.
Right?
And the questions that I have is more technical. The questions that I have is the surface questions. The questions that I have is very technical. My questions are things like, why is Coulomb's law and Newton's law of gravitation so close to each other? You know,
okay.
why is it that we haven't found a graviton? Why is it that the force of attraction is only attractive and it doesn't have a repulsive force? Why is it that when people see people floating on the ISS, they say it's cause of gravity? No, they are in free fall, you idiot. They are falling. That's not because there's no gravity and shit starting to float. So I mean, there's two sides of this argument that's totally.
Why are you a flat earther?
What you mean? Because
I mean, just everything you've said is right. So you know, in that sense, I'm not arguing any of that.
Because what I'm trying to get you to realize that from my observation and from my perspective, if I get on an airplane and I fly, that thing is going to fly straight, whether the earth is curved or flat. So from using the equivalence principle, from the view of the observer, well, to me, the equivalence principle is that the situation would be the same, whether you're in outer space or whether you're here. And what I mean by that is that if you're in outer space and you're following a curved line, that it would still appear to you as the observer that you're going straight. Am I correct?
Look, you keep harping back to general relativity. I want you to just focus on stuff that you and I can see. All right. I told you in the beginning, this is a model. You can accept or decline that model, but you can't change the laws. Okay, so let's just leave that the why it happens alone. Now you spoke about the aeroplane. The aeroplane just simply follows the Earth around because the Earth is a sphere, and it has to, because the aeroplane uses the air that's around the Earth in order for it to do what it does. Rockets don't need to do that. Okay, so let me ask you some questions then, because now I don't have to argue that space actually exists. When you look up and you see a constellation like the Starlink constellation, where you've got about 60 odd satellites in a row, right? How do you think those satellites, you said you think the Earth is flat. How do you think they are going around? They travel about 10 times faster than any fighter jet. Okay? How do you picture them going around the Earth? I see them orbiting the Earth because the Earth is a sphere. Okay? How do you see them?
I see them going around the Earth.
So you do have a view of how the Earth looks.
I mean, I just thought about that just now when you said it.
What do you think keeps them up there?
What do I think keeps them up there?
Wendell, they fly 10 times faster than any fighter jet. They keep in perfect formation, 10 times faster than any fighter jet. They never need fuel. What do you think keeps them up there? I mean, you're a practical man. You have to be a practical man to be a businessman in a restaurant. Please tell me what keeps them up there.
Solar power. I don't know the extremities of what's going on with the ISS.
It's nighttime when you see them, Wendell.
So you do realize that, you know, solar power charges batteries and things like that.
Yeah, okay, all right. So you think that...
But I'm not going to debate you on that.
Some sort of... Wendell,
I'm not going to debate you.
No. So, Wendell, you think that solar power is going to drive something 10 times faster than any known fighter jet? Why the hell do we have fighter jets that need fuel, that need to be refueled in the air? That we can't fly a jet that fast. Why not?
Am I paying for petrol?
Why we pay for petrol is a good point. Okay, do you understand?
I'm pretty sure there's plenty of reasons.
You understand that to think that these things are going around in a circle is absurd, Wendell.
Okay.
And yet, orbiting a planet explains it perfectly, because, like you said, it's falling around the Earth. That orbit explains it perfectly. Why isn't your default that one? Why do you have to pick? Why is your default the absurdity that these things could be going around in a circle above the Earth, no fuel, 10 times faster than any jet? And actually, I've got another thing going for you. Think about those things that are up there. We can see them, right? So the sun is shining on them. The sun is reflecting on them. It's dark. Where the hell is the sun, Wendell? Why doesn't that bother you?
Why does it what bother me?
Why? The sun is gone. It's dark, and yet you can see those things that are reflecting the sunlight.
Because they're closer.
Come on, you're a practical man.
Because relative to my position, they will be closer to the sun. They obviously will be receiving sunlight.
But it's dark.
That's just common sense. It's dark for me. So let me tell you something, Professor. You go to one end of a house, and I go to one end of the house, and you cut your one little light on or your little lamp in front of you. That's not a valid argument, because that ISS would be closer, or whatever object you're talking about would be closer to the sun in relation to me, which would be further away from the sun. Now I've seen pictures that make me say, hey, the earth might be a globe. And like I said, those pictures are like pictures where the clouds above the sun. To me, that's not a basis for the flat earther debate. That's a base for the globe debate, because if the earth is a globe, we're going to see the sun is going to appear to be lower than the clouds, when we know that that's not possible. The sun is not in the damn clouds. So there's certain arguments within, your model that I totally 100% agree with. I just don't understand the why certain things happen. And I know for me and my observation, everything appears to be flat, motionless, stationary, and that the luminaries in the sky seem to be rotating around us. That's what it seems like. And it seemed like, and even some great thinkers, I can't be too retarded, because some great thinkers like Aristotle thought that the world was geocentric for some point in his life. And we know he was a genius, just like Newton and these other guys. He was a predecessor to these guys,
So I don't think for a minute that I think you're quite an intelligent person. Okay, so don't give yourself. Don't ad hom yourself. Okay,
no, man, we're pretty loose.
I think you're intelligent. I just think that you've got some reason that's not based on evidence that you want to believe the Earth is flat. I just want to correct myself. 3,000 over 10, 0.5 is 300. I said 343,600. I think I said it's 343,765 miles. That's how far the sun would be, Wendell, if it was.
You were pretty close with just a bit of mental arithmetic. Come on.
Okay.
That's like going, I got 99%, but I want to get 100.
I have OCD with mathematics. Okay. All right. So Wendell, 343,765 miles away is how far the sun would be if it was 3,000 miles up in the sky. Now, Wendell, so I want I've got you to confirm that you actually think the Earth is flat like a circle and things go around it. I know you didn't expect that, and that's why I gave you the satellites. Okay, all right, because I needed you to. I want you to actually bring in your mind what you think the flat Earth is, and you've done that. Thank you very much. You think the Earth is flat like a circle, and these satellites go around it. So now let's get back to our sun, which you said before what you thought was about 3,000 miles high.
I did not say that. No, you're putting words in my mouth, brother. I told you I did not subscribe to that.
Okay.
You're putting words in my mouth, brother.
Okay. To be fair, Phil, he did say he doesn't give any particular distance for the sun.
All right. Okay. All right. So
I know, and to be even fairer, I know that the sun would have to be further than 3,000 miles away. I think I made myself pretty clear on that as well.
All right. Well, actually,
the moon is supposedly, 250,000 miles away? Y'all trying to tell me that the sun is closer than the moon? I mean, come on, man. I just don't want to debate the distance. I think that there's no accurate way to say that, it's 93 million miles away, even though that the math checks out. Do mathematics. So mathematically, we can say that this is a very, very good theory that this is 93 million miles away, because we've come up with a model that somewhat works, but we know that it does not work in every situation. And that's why you have scientists now trying to think of new models that the situation that works in every situation, whether it's subatomic, or whether it's, billions and trillions of miles away. So there's problems with your model that you guys don't describe, that you're unwilling to talk about.
Certainly not the idea that the Earth is spherical. That model, and there's no problems with that. So let's see if we can focus. All right. So 343,765 miles away. That's how far the sun would be. Were you looking at it? When you're looking at it, now the sun's disappeared, hasn't it? Because it gets dark. Would you agree with that?
Definitely.
Okay. So if it's at 0.5 degrees, in other words, the sun is still clear above the horizon, it's 343,765 miles away. Right. How far do you think the sun would have to be so that we don't see it at all?
I did the math, brother.
Well, I'm not even going to try to do the maths on that. Okay, because that would be because I know that it would, even the 993 miles, a million miles away, would not be enough for me to not see it at all. You see, Wendell,
I disagree. I disagree. Because I mean, because the same logic that you're applying to the sun, we can apply to stars. We're not going to see these stars at every time. There's going to be, the reason why you can't look out in front of you directly ahead, go stand on a mountain and see stars on the horizon, is because atmospheric, refraction, interference, or whatever you want to call it. There's certain things that humans have limitations. And as certain things get distances away, we're going to have more trouble seeing them. Because I can make the same argument to say, well, why is it colder on top of a mountain than at the bottom of the mountain on the equator when the sun is shining directly overhead? The person on the top of the mountain is closer to the sun than the person at the base of the mountain. And all of this is, I'm just thinking of off the top of my head because you said that. But if a person at the top of the mountain has snow on it, and the bottom of the mountain is 90 to 100 degrees, it's way harder. So regardless, that person at the top of the mountain is closer to the sun. Why is the bottom of the mountain?
Why do you think it is? I'd love you to have if a student said that to me, my response to that student was, I want you to have a bit of a think about that. Well, and let's do that, Wendell. Why do you think that it is colder?
I mean, I've already thought about the logic, I guess.
What did you think about
it? And we went through the different layers of you went through the different layers of the atmosphere and so on and so forth. And then you get into this idea that I think is absurd, is that the less molecules that you have, there's not going to be any radiation, nothing to radiate the energy, which makes sense until the point that we enter a molecule into that situation. So the minute I put a molecule in there, the radiation should directly go to that molecule. I seen a guy on Action Labs, man. I don't know if y'all watching, but Action Labs is a great dude for doing experiments, man. And he took a vacuum chamber and he took a laser, put something in the middle of the vacuum chamber. What he was trying to show was that heat radiates, energy radiates even through a vacuum. So even though that thing was sitting in the middle of that vacuum chamber, it still got hot, brother. It still registered a temperature. So if I'm out there in the middle of outer space and I can see and feel the radiation of the sun, it should radiate me in the same manner that laser radiated that little ball, that nickel ball in the middle of the the vacuum chamber.
I'd like to say this, all right? Mm-hmm. You are a million times smarter than most flat earthers I've ever come across. Okay, all right. And so far,
thank you, sir.
And very little that you say is wrong, actually. All right. I think you've got fragments of things that are wrong, but generally speaking, you just would repeat what I would say. Okay, so.
Hey, coming from you, man, that's a very good blessing. That's a thank you, sir.
Well, you're definitely smarter than the majority of flat earthers who have on the channel, because you can click a Zoom link and join the call, which instantly puts you above the majority of them. So good job.
I think
this is very entertaining for me, man. I hope
he's even better than that. Look, you've got a pretty good understanding of that, and your description of how of radiated energy is good. Now I need to get back to this flat Earth thing, okay? Because that's the sticking point. All right. Now, we've established you yourself have established that you think the Earth is like a disk, and that the things go around it like that. But you realize that those things would need to have, because you have a pretty good understanding of energy from the certainly heat energy, and you understand that they would need some sort of energy to go around a flat disk like that, wouldn't they?
Definitely, brother.
Okay, so and what you saying to me, and what you're saying to me, Wendell, what you're saying to me is that that these things go around just by themselves. They don't fall. Why don't they fall to the ground? What keeps them up there? What keeps them up there at the speed that they go?
Well, definitely they putting off a shit ton of energy, excuse my French, on their own. If something like the sun, if something like the sun can shine as bright as it does, it definitely packs a wallet when it comes to energy conservation. So potential energy and kinetic energy would definitely be there in the sun to keep itself moving. I understand, perpetual motion ain't real. And let me clarify another thing. I don't know exactly how the Earth looks. Like I said, I know that Antarctica is real. So we're not going to have the debate about the ice wall and this and that. Now, as far as the whole schematics of the Earth, I'm unsure, and I'm reluctant to believe everything that's taught to me. So when I see some discrepancies in some of the models and some of the things that people say and some of the things that teachers are teaching the kids, I say, hey, that ain't cool, man. We got to figure out the right way and let kids know that this subject is still open for debate. Use your mind, and you might be smarter than Einstein. But if we restrict our children to learning broken bases, things that we ourselves have identified of having problems, and not encouraging our kids to excel through that, then this conversation is dead. Then the future of the world is destroyed. And that's why I don't think that our generations are as smart now as they were back then when people thought the damn Earth was flat. Right now, the IQ seems to be going lower.
No, it's not actually. It's
maybe
the advances in science and technology that's happened in the last 100 or so
individual
years.
people are smarter, but as far as the masses, it seems to be dumbed down. Individual people are learning from their predecessors. So
no,
yeah,
my kids know a hell of a lot more than I ever did about various things when I was their age.
Good.
Simply because they have to deal with more. They have to deal with technology that I had no idea about, and I still struggle with it now. Okay, because
I'll tell you what, you got people like people like Isaac Newton, Albert Einstein, Cavendish, Planck. These people were one-of-a-kind people. These people are not born on the Earth every day. It takes a certain kind of mind to create these constructs. So
totally agree.
Yeah, so like I said, and this is coming from a time where people believed in ether. So I don't think it's absurd.
They didn't believe the Earth was flat for more than 2,000 years.
That's fine. That's fine. But there's people that's 2,000 years ago that's smarter than most of the population today that thought that the Earth was flat. And that's my point. And that's what I said.
Do you get?
I mean, you may disagree.
Do you get why? Do you get why? Why, for instance, they didn't have satellites orbiting the Earth. They didn't have any of those sort of things. They didn't have the tools to know and understand at that time. But 2,000 years ago, more than 2,000 years ago, they knew that the Earth was a sphere.
I'm reluctant to believe
why is it? So Wendell, why is it more than 2,000 years ago, plus all of the science in between, plus all of the physics in between, plus your heroes, Einstein and Newton, all of these people, all of these people, Wendell, know the Earth is sphere. Not only that, Wendell, we have satellites orbiting the Earth.
I challenge them.
Wendell, I have a dish on my roof, okay, which was installed by a guy 12 years ago. Now, when for obvious reasons, I was absolutely enthralled in what he was doing, I watched every moment of what he was doing. We talked about the angle at which he would install this satellite dish on my roof so that I could get the television. We spoke about it. He and I had a really long conversation for obvious reasons. That I have not moved that satellite dish at all in those 12 years, not 1 inch.
Okay, stationary.
It still points to the satellite up there. Now, if the satellite was going around, whizzing around your Earth, can you please tell me how I would be getting the satellite signal?
It's more complicated than what you're talking about for TV, right?
I want to hear the complication.
You're talking about for your TV, right?
Definitely my TV.
Hey,
yes.
Phil, all the dishes in your area, which direction do they point?
They all point 37 degrees. Why?
So roughly north from your direct
they point north towards above the.
It's funny you say that, because all the satellite dishes around me are relatively the same, but they all point south. That's strange.
Now,
I get that.
Wendell,
So let me tell you. So let me ask a question, because like I said, I don't like to get into things I don't know too much about and sound like a total idiot. So
no, you're not a total idiot.
So I would like to ask a question. Is that not possible on a flat Earth?
No, it's
and
not.
Could you explain to me why?
Well, it would need to stay in one place, wouldn't it?
Exactly.
Well, also the trigonometry wouldn't work, would it, Phil? If you were to take all if you were to take all of the angles of all the dishes, then it wouldn't work on a flat plane, would it?
Let's just say that that we don't even go that far to the mathematics of it. This thing, because I'm appealing to your understanding of energy, which is pretty good. Okay, because I know that you don't want to think about things that are absurd. Don't you think that something up there that's above, that's 30, that my dish is pointing at 37 degrees, is pointing up there, is going, and in fact, everybody else where I live, you see dishes all over the place, all pointing to the same place. What's holding it up there?
Some type of energy.
Some
type of energy.
Some type of energy, yeah.
Come on, Wendell. You're pretty good with the energy.
Well, like I said, I'm pretty
Who put it up there?
I'm pretty good with understanding your model. So I don't know the extremities of how satellites work to have a debate with you on satellites. So you're telling me that satellites don't require fuel. Hell, that's a big plus for the globe model, because that would mean that these things are following that orbital path that we just talked about, and they don't require all of this extra energy. So I mean, yeah, of course, but I'm not going to debate subjects that I've never studied satellites. I don't have the level of education that you do, and I don't know for the people that build these satellites how they maintain what they're doing. I can't say whether they're fueled up there or not. I can't say whether the pictures that they're sending us back from these satellites are accurate. I can't tell you any of that. The only thing I can tell you is that, hey, yeah, this picture right here came from Apollo 1. But, you know, and the same note, I can't debate you on satellites. Just like I told, brother last week, I can't debate him on sextants. I've never researched sextants. I'm just a science nerd who feels like, from our perspective, the Earth is flat. And so I just like you.
How is it from your perspective? That's what I'm trying to get at. I'm still stuck on that.
Because for me as a human, outside of space travel, outside of taking a rocket and going to the moon, me as a human in my day-to-day life, use straight lines and flat stationary surfaces to map out my life. So most humans, regardless of their level of education, if they were not taught that the Earth was round, it would take a great mind to come up with that assumption in the beginning. And it would take an even greater mind to create the mathematical structure that goes along with it to make this crap work. You understand? So like I said, mathematically, the Earth is a globe. I'm not going to debate you on it, but I'm telling you that from the view of the observer. If I needed to get from America to England, I'm going to go in a straight line. Now, it may be shown as a curve, but just like I explained to you, we're walking towards the globe. Hey, that's a beautiful picture, bro.
Okay, so, well, this is more than a picture, Wendell. This is an actual photograph.
Taken by what?
Have a look at the name of that up there, Chandrayaan-2. This is the rocket.
What's that? It's an Indian satellite.
Yes, this is the rocket. This is taken from a rocket. This is a rocket that took about 43 days to get to the moon, and the Vickers.
How fast was it traveling?
The Vickers rocket, 28,000. Can't remember off the top of my head, but around about 28,000.
So using your math, did this thing take some detours or something to the moon, or is my math off?
No. Let me explain, please, Wendell. You didn't let me finish. So this went in an orbit. So it took 43 days because it didn't just go straight there. It didn't say, "Oh, there's the moon. I'll go right up to it." This thing went around in an orbit, ever increasing orbit. So it started with almost a circular orbit, and then a wider and wider and wider elliptical orbit until finally it reached the moon, and that took 43 days. Okay, before it branched off and then actually orbited. It's still up there, by the way, Wendell. This orbiter is still orbiting the moon as we speak. Okay, now, but Wendell, because I want to get back to flat Earth. This is an actual photograph. An actual photograph of our beautiful planet. Why doesn't this cause you to pause on your default flat Earth?
It does. Anything I see causes me to pause, but I do have the power of discernment. So I don't think that everything I see is actual factual, and I have reason to believe that, the powers that be want to keep people aloof.
Do you think I'm a power that be that would want to?
Definitely. I think you're an intelligent guy who's definitely followed the model and the structure to accomplish what you set out to accomplish.
Wendell, I was at the center when this photograph was taken.
Were you on the rocket when it was taken?
Why would I need to be, Wendell?
Why would you need to be exactly? Why would you need to be at the center?
Wendell, stop. Am I on the camera at the Super Bowl?
Exactly.
Am I at the Super Bowl if I'm watching it from my lounge room? Is it still not the Super Bowl?
Exactly. That's the point of whether you were at the lab or not. Whether you were at the lab or not doesn't matter about the picture, just like you just said about the Super Bowl. I said what you said and rebuttal to you saying that I was at the lab when it was taken. I'm not denying that they took a picture. I just don't know the authenticity.
I'm just trying to tell you that no artist made this up, Wendell.
Like he was there. They told it to take the picture, and it took the picture.
This is a beautiful
there
picture.
It was on their screen.
Exactly. That's
pretty gangster, man.
So, well, I'll tell you something, Wendell. It was kind of rare.
Hold on, one sec. Did you just say to a picture of a rocket that Phil Bell worked on, taking a picture of the Earth? Was your response, "That's pretty gangster, man"?
Yeah, man.
I just wanted to check you.
It is pretty gangster.
That's pretty gangster.
Phil, that's pretty gangster, man. That's the new thing.
Hell yeah, man.
Well, Wendell. So this picture here, it's not like when the rocket is going around, is going in an orbit, that we get a picture like this all the time. Okay, the camera's got to be just in the right place in this orbit for this to happen. Okay, so in other words, it's not that easy. So most of the time, all we see is the blackness of space. And then every now and then the rocket comes in the orbit at just the right angle, so the camera has, and we take a picture like such a beautiful picture like this.
Right,
and,
because
and
like I said, the first thing.
Not only that, what country do you think that is? Doesn't that look like Baja, California?
Yeah, yep. I guess the bottom piece.
That really does look like a bit of Mexico in the United States, doesn't it? Yeah.
Yes, it looks like America's penis.
Like I
So
said,
Wendell,
that's
Wendell,
pretty gangster
we
picture.
agreed that at least I don't have to argue with you that space is real. And this
Space
is
is
so
real.
most flat earthers would say, I don't believe this picture because space is fake. I don't have to argue with that with you, and that is just
well. Hopefully, you're not arguing with that with anybody, because that would be the equivalent of arguing with a brick. We can look outside and see things inside outer space, so that's not an argument that we're gonna make. But you know, if somebody was to come to you and say, "Well, how fast was the rocket going? You know, what's the shutter speed on your camera that took the picture and things like that?" Then you would have to explain, because, like I said, things have to be. This argument is technical. This is not an argument for preschoolers. So when I look online and I see people with the preschool, you know, rhetoric going back and forth, I ignore it, man, because there's obviously no hope for teaching a brick. And if you are successful with that, man, brother, I believe anything you tell me.
Yeah. All right. So Wendell,
about 10 minutes, guys, and we're going to be getting to super chats and questions. Okay.
Yeah. Let's wrap it up, man. Let's wrap it up.
That's all right. So Wendell, I think this is a great one to go out on. So I want you to have this image burn in your mind. I
saw a dope one before from I think it was a Chinese or a Japanese satellite. Like I said, I don't know the authenticity of these things. I think it's called the Himawari.
Himawari, yes, that's a Japanese, Japanese satellite.
Yeah, fucking kind of hard to say, but
yeah, that's the one that's the one that we Australia, we use that for our Bureau of Meteorology. So that's our weather satellite that we use over here in Australia. You think the governments in Australia are just total idiots? And there's 10,000 there's Japanese CGI artists just ready waiting to paint this for our government.
Well, where we probably have a strong disagreement at is I really feel like the governments are pushing towards a one world government.
Well, maybe that's true, Wendell. But the point is, they are not They are not a team of Japanese CGI artists painting the world, to fool us Australians and everybody else in the Pacific.
It's a computer generated image. It's a computer generated image, and these guys all get funded from the same sources.
It's a photograph, Wendell. It's a photograph.
Right. I told you I saw a couple of pretty dope photographs from a couple of different satellites, not just this one here. Well, I saw a couple of dope ones, but I still retain my power of discernment to say, is everything being shown to me what it is? Just like I told you with the picture of the black swan. I don't like to debate pictures because sometimes pictures don't tell the whole truth. And that's something that we got to identify. Now, like I said, if everything about this picture is 100% actual and factual, then hey, the Earth is a globe. And long as you can get to see this picture, you have your proof that the Earth.
I'm so clipping that, Wendell.
You're absolutely right.
Flat Earther admits the Earth is a globe. There's a short. I'm releasing that short tomorrow, guys.
I never said that.
Wendell,
Wendell,
I listened to you before, and I had a feeling that you were. I couldn't put, and the reason I wanted to speak to you is because I couldn't believe that based on what you actually do know and your understanding of stuff that's happening around you, and including your pretty good understanding of your heroes. Newton and Einstein, I couldn't believe that you actually did think the Earth was flat, right? And I think that you've sort of summed it up and said that you don't know. Well, Wendell, I'm here to help you a little bit, okay? And you can accept this or not, but you are looking at our beautiful planet. This is an actual photograph. This is no CGI. This is no multiple lenses. None of those things. This is an actual photograph of our beautiful planet, taken from a spacecraft that's on the way to the moon. So I'm going to leave it like that, okay?
All right, and that's a gangster picture.
Gangster.
That's a gangster
definitely
picture,
a gangster
man.
picture. Thank you very much for coming.
No, I appreciate really y'all having me, and like I said, just for your viewers, there's some discrepancies with the model, and that's why people like me think that the Earth is flat. I think from my perspective, that
Hopefully,
for everything that I
Wendell,
use in life, that the Earth is flat. You know, and there's plenty big scientists that have problems with the calculations that we get from gravity and
not
whatnot.
with the Earth, not that. So Wendell, no scientist has any problem with
I
that.
didn't say that. I said there's plenty people who are much more intelligent than me who believe that the Earth is flat.
No,
Now, and I
not.
said that there's scientists out there that have problems with the model. So that's why we're always trying to create more models. So in my head, even if the Earth is a globe, we can still break it down into our flat physical observation, because that line that we travel, even though it's curved, like I explained to you guys earlier, it appears to us as being flat. We don't appear to have a force that's drawing us together when we're on the equator walking towards the North Pole. So with that being said, we're both walking a straight line path through curved space-time. And if that's something that we can get people to understand, then it's a duality to the situation, because from my observation, I'm walking a straight line path. Its path is not curved. I am the observer that's walking this path. You, the outside observer, would see the curve. I'm not the outside observer.
So Wendell, look, I presume you're describing Coriolis in that particular case. Wendell, I mean, as we're bringing this to a close, I think that you're smart enough to look back at this particular discussion we've had, and there's a few things that I'm just going to sum up. I started off by showing you that boats do go over the curve. I described to you how gravimeters work. I showed you how it's impossible that the absurdity of the sun, going away and then disappearing, because I mean we still see the stars, so I've explained all of that to you. We've gone through that. I showed you the pièce de résistance, which was the photograph from Chandrayaan-2. And I think that you're smart enough to put all that together and change your default. So I'm not going to make you commit to that right here, although I think you kind of have. Although I think you kind of have, because I love your gangster description. Really,
Space is gangster. That's a T-shirt.
Really,
Space is gangster.
I buy one from you, man.
We should replace the word Chandrayaan-2 with gangster. That is just fantastic.
The gangster rocket.
So Wendell,
awesome.
I think that you, if you gave that enough thought, because I think that you're a serious person in that sense, you'll come back and we'll both agree that the Earth is a sphere. Okay.
Yeah, hopefully we admit again. We'll think about it.
Right, before we get to super chats and questions, Wendell, a lot of people have been asking about your restaurant. What is it you serve? What is your restaurant? What's the kind
Seafood, man. I'm from Charleston, South Carolina, and we got a Geechee Gullah culture. So it's indigenous seafood. Y'all look it up on Facebook. It's at Atlanta's Restaurant Lounge in Mounts Corner, South Carolina.
Well, if ever I'm down in that area, I will pop in. I do like a bit of
seafood.
Oh,
yes, seafood. Yeah, man. Snow crab legs, lobster tails, good old shrimp, oysters on the half shells.
Sounds good. I'm trying to lose weight. That's not good for me.
Seafood is good for losing weight, brother. Just don't put a bunch of butter on it.
Yeah, but
all protein. All protein, bro.
Butter makes it taste good.
Right? Just use some garlic, man.
Right. Right, super chats. There's quite a lot of super chats. Thank you very much, guys. Thank you to both of you for coming. So we'll get through these questions and then get out of here for tonight. The plot hole's been a member for 29 months, says he's been bashing his head against the wall because there's lots of mental gymnastics. Yeah, that's a feeling we have around these parts quite often. String News 1 for $5 says, this is for Isaac Newton. His fig cookies are delicious. Fig Newtons are not named after Isaac Newton. They're named after a town somewhere. In Massachusetts, maybe? I might be wrong. A madman with a soapbox, $5 says, Wendell, our eyes and our senses lie to us all the time. What do you think about that?
They do. They do.
Yeah.
They lie to us all the time. Just like when you see the boat floating out in the middle of the ocean, you know that boat's not floating. common sense to tell you that it's not floating anyway.
Boats definitely float in the oceans. I was a sailor.
You know what I mean, floating in the air, man.
Well, the boats I was on actually sunk, but on purpose, because, you know, they were submarines.
Submarines, yes, sir.
Alison, for $5 Australian, says, Wendell, evening schools are a thing used by many adults. It's no shame to get some basic physics classes. There's no need to be ignorant. And I think that what he's trying to say there in the few words that he has is that you're this close to kind of understanding.
I agree with that.
But what he fails to understand is that, just like I told Professor Bell earlier, if I wanted to come to your conclusions, I would have no problem coming to your conclusions. I got all your equations. You know, I haven't been to school in years. I'm 42 years old. And so most of my life wasn't focused on, you know, like Professor over him. Most of my life wasn't based on continuing education with these math products, math problems and things like that. So I admire the guys that were able to do what the professor is doing. I'm just one of these guys that have my own mind. I got a pretty high enough IQ where if you give me these equations, now I'm not going to sit here and tell you I can go through Einstein's field equations. Never got that far, buddy. But to pass a calculus class, honors calculus class, things like that, top of my class is no issue. If I wanted to do what you guys are doing, I could. It's just that's not my drive.
I just think that if you went all the way and did the studying to help you understand the few misconceptions that you have, there's only one conclusion that you could possibly draw. The reason I think that, well, the reason I know the Earth is a globe is because I'm able to draw the conclusions because I've gained the knowledge and skills to draw those conclusions. And like I was just saying, and like Phil agrees with, you're this close. And, you know, calling you ignorant isn't an insult in this case. You are ignorant of some of the basic facts, but that is something that can be fixed and isn't necessarily a bad thing.
You're a smart
cool.
bloke.
Like I said, I don't take that type of criticism to heart anyway. You know, it's all entertainment. I hope the people enjoy it and they can get on there and talk as much crap as they want.
Wendell, you were gifted with a good mind. Please don't squander it.
No, I think what I'm gonna do is I'm gonna start me a little YouTube channel like this, man. Maybe I can, you know, get me some viewers on there.
Hey man, I would love to see a YouTube channel about your restaurant. Like, you know, I love cooking. I cook everything fresh at home, and I love to learn about how restaurants work and stuff. And I think a restaurant like yours,
the baddest chef around, bro.
Man, a restaurant like yours, just a day-to-day kind of running kind of YouTube channel would probably rack up views. Lots of shorts you could make just about this is how we do deep fried crayfish, you know, 30-second clip. That'd be great. I'd love that.
Damn, dude, that's smart, bro. I'll keep that in mind as well.
Peter's Prime for $5 Australian says, Professor Phil Bell, you give me faith in Australians being smarter than certain other numbskulls that appear to be down there. Mitchell from Australia. I honestly don't know how you can live in the southern hemisphere and think the Earth is flat. It blows my mind.
I agree.
Yeah.
It does.
And everyone say hello to Mark in the chat who's dumb.
Right?
Sorry?
I said it's a lot of those flat earthers from Australia, am I right?
Yeah, which confuses me.
I think
really confuses me.
I think the movement kind of started in England and Australia, man, and you know, which is funny
here.
Because it's the same group of people anyway.
we have a bunch of birds here we call galahs,
right?
And that pretty much, it's pretty much as a group, are what those flat earthers in Australia are. Galahs. Actually, maybe I'm insulting galahs. I think your description was better. Brick, you said.
Brick.
You said they had the intelligence of a brick. I agree with you.
Don't make any sense to argue with a brick, brother. You're not going to win.
Oh, I talked to flat earthers. Oh, sorry, bricks. Yep, sorry, no. Anyway, String News $1 says, the idea of anything that comes back to you is absurd, and yet the idea boomerangs. Boom. Alison for $2 Australian says, Wendell, do you agree that refraction exists?
Of course. I mean, so what it is if you get some water droplets, especially some condensed, droplets or gas or whatever in the atmosphere, Oh, we don't even have to use the atmosphere. We can use our house. I'm just thinking off the top of my head. You grab your flashlight, turn your stove on, make the house a little bit smoky, shine your light through it, you're going to get a whole lot of refraction because the light's bouncing off of these different molecules all over the place. So, I mean, of course, there's going to be some refraction when you're talking about the atmosphere and you're talking about light. You're also going to have dissipation. You're going to have where the energy from the light kind of spreads out as it goes further away from the source of the light. So I mean, it's a lot of things with it.
I've got a video on my channel that actually covers that refraction. So
thank you, Vincent.
Have a look at it.
Okay, follow-up question to that, Wendell. Do you believe that refraction has been quantified?
That's a question I'm not prepared to answer.
Okay. Can I suggest for a little bit of homework you look up the works of Dr. Andrew Thomas Young, who is the world's leading expert on refraction?
Right.
And also, Newton was actually the base of our understanding of refraction.
Newton was a genius, man. But, you know, and I know you hate this word. You know, fight the flat earth. I know you hate what I'm about to say. But based on our observation, we create the mathematical construct to match our observation. So what we do is we view an event, and I see you shaking your head, yeah, we view an event. And what we do is we create a math that matches that event. Okay.
Yeah, no, we create math that describes the event that we just saw. And in the case of Newton's law, Fg equals gm1 m2 over r squared, that is a literal description of the observations that he made. And the observation was simply that there appears to be an attractive force that is proportional to the mass of two objects and inversely proportional to the square of the distance between them. That's all he did. He said, right, that appears to be happening, and this is the mathematical description of it, which is why it's a law.
And then you get Wendell that says, yeah, your math is correct. Now, what is the source? So what is the force carrier for?
Yeah, but that's kind of irrelevant at the end of the day. If the law works, then it works.
The law.
But the law obviously breaks down in certain instances, and I know
in relativistic circumstances, yeah, which is where general relativity and special relativity comes to be useful. But we live in a Newtonian world, so all that matters to us is Newton's laws, really.
Because
I can fire a ballistic. I can fire a cannon out of a cannon. A cannonball out of a cannon, right? And I can describe to you that path of that cannon, I can describe that to you using Einstein's equations, right? It would be long and complicated and boring, but I could do it, right? But there's no point because I can do it so much simpler just using Newton's laws of motion and Newton's law of gravity. You know, they would both describe the same thing, but you know, there's no point in me doing the more complicated thing when I can do it perfectly well with the less complicated thing.
I agree. If I'm going to explain to somebody why two objects fall to the ground at 9.8 meters per second squared, is because I'm going to use Newton's law. I'm not going to go into Einstein's field equations to try to explain why things fall at the same rate. But,
Wendell, you're getting better and better as we go along.
Dude, this is common knowledge, man. I've been explaining to my kids for years why things fall at the same rate. Before we got into this whole flat Earth thing, like I said, I saw a couple of things that they said that I agree with, but it doesn't by any means stop me from using your math to come up with your answers. That's not the problem here. The problem is the difference in the perception of the world that we live in.
I think we've got even that much closer. and you've actually gone up a notch in my estimation by telling me that you tell your kids about Newton's laws.
Yep.
Oh man, my kids are
I actually appreciate that.
Yeah. Wendell, there's a flat earther in the chat called Shane that would like to know how to get hold of you. The best way would that probably be through Facebook?
Yeah, tell them to hit me up on Facebook.
Yeah, Shane, I'll send you the link to his Facebook profile on Discord, bud, alright? Then we have next, Neil Paddy Freeman, who's been a member for 10 months, says, Wendell is all babble with no techno. Okay then. Alison, 5 Australian dollars. There is no problem with the globe. The problem is your lack of understanding. You lacking intelligence is not an argument. Ooh, them's fighting words.
Them fighting words there.
Stringfellow Hawk for $10. Just because something is difficult doesn't mean we can't do it or haven't done it. Guess what? We've been to the moon, and it was very difficult. You not believing that doesn't change that.
People died on
I never said whether I believed it or where I didn't.
No, to be fair, you didn't.
That guy again is making an assumption. He's making. I listen at a lot of the comments and I say, well, you know, there go again with that 80 IQ, man. Most people.
And they're just so used to the normal, like 99% of the flat earthers that we have on here say the same things.
Because the real conversation is over their head. If they want to get down into the nuts and bones of how things work, it's over their head, and they're not capable of understanding it. They're here for the entertainment.
This is good entertainment, though. You have to agree. The Rabbit for $10 says, Wendell, do you believe in the other 7 planets, and are they globes, or if Venus and Mars are also flat? Or if they are globes, then why is the Earth the only flat one?
It's Paul. just because the light on my ceiling is round doesn't mean
you don't buy
floor is round.
He asked, do you believe that there's other planets there? Do you believe that Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune?
I advise him to go back and listen at the this debate in full, because I definitely explain that those things out there are definitely physical objects, and they're definitely circular to my eyesight. Yeah, they're definitely round in my eyesight. So that's not things that we are going to debate. I got 2 eyes, man. Tell your guy to go back and watch the whole video.
Okay.
And we've invented telescopes too.
Yeah, they've been around for quite a while. Lance Jess Ellis for $10 says, when I was younger, I thought dancing was easy. I'm not immediately a master at it. It's a conspiracy. Using magnets. I'm sorry, but as a fellow PhD physicist, that's what you flat earthers sound like to us.
Well, she's a PhD physicist, and like I told people, in order for you to make a valid argument that the Earth is round to a person like me, you got to have a PhD. A normal guy can't debate me on.
I don't have a PhD. I've just got 2 bachelors.
No, you don't.
That's pretty good. Now, like I said, I enjoyed the whole reason I got into this is because I enjoyed debating MC Toon and Fight the Flat Earth, because they got an intelligent argument. At least I can have a conversation with these guys about the technicalities of how the Earth works. That's fine enough for me. The rest of the people, hey.
They're bricks, aren't they?
Bricks.
Abellis UA for $5 says, Wendell, if the Earth is flat, what's underneath? Is it turtles all the way down? And why can't you provide pictures of the edge and pictures over the edge?
To answer the first question, it's a big giant turtle, right? I think his name is.
Yeah, he's called the Great Atuan, actually.
Yeah, Lenape, the Great Turtle, and he created us humans and everything, and we just floating on his back. And
the turtle with 4 elephants.
Oh, maybe, yeah, you're right. You forgot about the lion.
Here you go. Here's the picture. This is what NASA doesn't want you to see. This is the actual picture taken by the Chandrayaan satellite.
And you know, it's so crazy because, you know, ancient Indian cultures, Native American cultures believe that America was Turtle Island. So that whole depiction of this flat Earth meme that I just saw this now is just a depiction of how the ancient Indians viewed Turtle Island. But I'm definitely not retarded, man. I know you can dig, and we ain't found a turtle yet. And I'm sorry, but I don't own a rocket or or anything able to go and take a picture of the edge of the Earth.
Tell you what, don't do the last flat earther that tried to do the rocket thing. It didn't end up that.
It didn't work out too well.
No, so we're not gonna, rest in peace, Mad Mike. Pieces, actually, a lot of them. Anyway, Brendan Kelly for $50 Australian says, "Whoa, I think we could save him. Maybe. We'll see. We'll see, Brendan. We'll see. Thank you very much, Brendan. That's very generous as well." Lance Jess Elias for $5. For my physics degree, I measured the distance to the sun 3 ways: parallax, spectroscopy, no container, and planetary motion. They all matched. Please explain why they all matched.
And radar.
Or like I said, I looked a little bit into parallax. That's the only way that I know that the 93 million miles came about, and I know that parallax was based on relative distances to things that we knew the distance of, I guess. All right. So the other things that he mentioned, I don't know, and I don't know how they all match up and line up with each other.
Look them up.
I would have to look them up to see if I have a valid
Professor
argument
Dave does a lot of
against
good
it.
explanations of spectroscopy.
Yeah, I might not have a valid argument against it, you know. But
Look them
right
up.
now, I'm not going to debate that.
It'll be good for you.
I
It'll be
will.
good for you
I
and
will.
your kids.
Uh-huh.
All right.
Design Song 1 for $5. Wendell is a quantification and a magnitude denier. If it doesn't fit what he feels, he denies it, therefore flat Earth.
Cool, you're right, dude. Another brick.
Okay, moving on. English UA for $5 says, Wendell, you cannot believe in Antarctica and the flat Earth. What shape is Antarctica, and do you believe in the ice wall?
I don't know nothing. I don't know much about the ice wall, man. I've never seen anybody try to photograph that one. I know that Antarctica is real. I know some a lot of conspiracies going on with Antarctica, whether you are a flat earther or a globe earther. There's some weird things that happen with Antarctica, and I think that part of that is naturally because not that much people have been there. So people are gonna imagine and speculate all kind of crazy things. Awesome, dude. People are gonna imagine and speculate all type of crazy things. What I'm gonna say is I think the Antarctica is there. I don't know the mechanics of how everything works. I know if you follow science, I think it was about a year or two ago, they discovered that high energy neutrinos was flowing from Antarctica and flowing into outer space, which is weird because it should be the opposite way around. You know, so I mean, there's a lot of things that's weird about Antarctica. I don't know. I don't know the exact shape of the Earth. I know that if I was to go take a trip to Antarctica, I would take a straight line path to that trip, and I would be in motion at that point, and everything around me is moving as well, like the stars and stuff in the sky seems to be in motion on my travel to Antarctica. So I would still be traveling a straight line path.
But you'd agree that it's that from your perspective, it could be the Earth that's going around, that's moving around, and those things are still.
It could be. It could be.
Okay. Yeah. Good to have because there's lots of proof that that is actually the case.
Yeah, I mean, like I said, but from my perspective, what I see is that I'm flat and I'm stationary. I don't see any movement. I get the math. I understand the math.
Measure it with a pendulum.
Exactly.
Anyway.
I know about Foucault.
Moving on. Lance Jess Ellis for $2 says, say thank you to Dr. Bell. He is fantastic. Bell, you are fantastic.
Thank you very much.
Stringfellow Hawk for $10 says, Wendell, why do you believe someone that says the Earth is flat because it was over 2,000 years ago, but don't believe someone from the same time that says it was round?
What you don't understand is I don't believe anything. What I believe does not matter. 1 + 1 = 2. So I've made a logical, explanation for myself of why I think that the Earth is flat. Mathematically, the Earth is a globe, but in my day-to-day travels, I'm traveling in a flat straight line down the geodesic, and everything, all of the stars are in motion. They seem to be moving across the sky every night. So in my perspective, we are in a geocentric situation. We are flat and we are stationary. That's my perspective.
Well, that totally contradicts what your heroes, Einstein and Newton.
They can still be my heroes. I don't have Einstein contradicted a lot of his heroes. Just go read all about it. And he was nervous himself about contradicting these heroes. And that's a problem. When you get people that's nervous, we don't live in the 1700s where the Catholic Church is going to kill you for practicing science. So, but we still created that same aura when it comes down to mentality of teaching people, because we get you stuck in a box that if you say anything against the norm, if you go say, hey, M theory might be how things work in the universe, oh no, you're a nutcase, you're crazy. So people are kind of more refrain from coming up with true and natural theories of why they think things happen the way they happen. And until we can break through that, we're never going to progress any further.
Wendell, let me just correct you on that a little bit, okay? So, and I'll give you from perspective of my students. If my students came up with some way out thing like that and said the Earth was flat, I would then be asking them to show me all of the evidence why they think that it is, okay? And then they would have to argue with all of the theories and all of the and I say theory in terms of scientific point of view, for all the evidence that contradicts that. So I would not be saying to them, you can't say the Earth is you can't say this, or you can't have your own opinion about what things are. I will be asking them to show me the evidence and show me. So I don't mark people on the basis of what I think. I mark them on the basis of what they think and how they support what they think, what is underpinning their particular point of view. Okay, so we don't go around in universities trying to impose stuff, impose information on people. We show them.
Some of them do.
No, they don't. We show them.
Try UC Berkeley, man. I mean,
no, they don't. Not even Berkeley. They don't. That's not how it works. Right? Lecturers don't do that. I get up there and I speak to you for an hour or 2 hours, and I'll give you some information that I know, and I'll show you some evidence, and then I'll be asking you to consider that. And when I test you, I'm not going to be I'm testing you on whether you understand the evidence, whether you understand how this puts together. It's nothing to do with what I think. It's not what I think. Okay, it's what the evidence says. Okay, that's what counts. So this thing that flat earthers say that we get indoctrinated, we don't get indoctrinated. Those people that come from universities, those people that complete their physics degrees or their science degrees, and they come out with an opinion. That is an opinion, that is knowledge based on evidence. Okay, they didn't just get told this. We don't go to university and then somebody just tells you stuff and then and doesn't give you a reason for why they expect that to be the case. Right? That's not how it works. So drop that from your lexicon as well. Okay?
Well, I won't because I will not, because to me, first of all, it's connotation and denotation. For me, indoctrination is not a bad thing. All of us have been indoctrinated, and that's a good thing. All right, now some people have been misled, but to be indoctrinated just simply means that you learned the doctrine. Whether the doctrine is correct or incorrect is another whole debate. But to say somebody's indoctrinated, we all have to go through school. We all have to pay our bills. We have to make money. So don't feel disgraced by somebody saying, "Oh, you've been indoctrinated." Your indoctrinated got you into places where you get to watch satellites and send pieces of rockets to the moon. So that doesn't mean it's not a bad thing.
It's not my indoctrination.
I mean, you learn. Well, you learned the doctrine. I don't see anything wrong with that.
It's knowledge that I've gained based on the evidence. It's not indoctrination.
I mean, I guess I see
nobody said something to me and then I just accepted it. I didn't.
I never said no. Right. You did the math.
Right. Let's move on to the next question. Rachbot for $10 Australian says, it's always great to hear Professor Phil Bell speak. Great show. Thank you, Rachbot. That's awesome. Brendan Cuskelly for another $20 Australian says, oh, I take that back. He seems to have lost faith in you because of something you said, Wendell.
That's fine.
I think we're going to have another talk with Wendell and Phil and see what we can do. Matthew Hooks, who's been a member for 4 months, says, geostationary orbits. Very simple. Happy to explain. I've got a good explanation of those coming up in one of my videos. Design Song 1 for $2 says, Wendell doesn't like science crushing his feelings. Are your feelings hurt, Wendell?
I think so. I'm going to go cry when this is all over.
Philosopher King Gaming, who's been a member for 19 months, says, Professor Phil Bell asked rhetorical question. Flerf, exactly. Also FTFE. Please try to pronounce... Oh, you're a cunt. Please try to pronounce membrane proliferative glomerulus Lorentheritis. Stop getting me to say things that I can't shut up. Design Song 1 for $5. Wendell simply wants to reserve a power to assert his feelings over math and science. More people think your feelings are hurt there, Wendell.
Yeah, right. I guess so, man. Awesome. I hope you guys don't think so.
Darren DeBaron for $9.99. I don't have a question, just felt like contributing. Howdy. Thank you very much, Darren. I really appreciate it. And then, as a member, he sent Howdy Part 2, and Howdy back to you. Neil Paddy-Freeman for £5 says, I correct my last statement. There is some techno-gangster in that babble. Yeah. Hashtag science is gangster. Siggy Sigwald, member for Club, says, I don't like your conclusions, no matter how right you are. That's the general Flerf one. And then Vincent Florquin for €50. Thank you very much, dude. Look for shadows on Antarctica pointing towards the sea. On the flat model, this would not be possible since the light source would be beyond the wall. Please, my friend, try to perform some experiments and cut yourself out from the insanity.
I agree with that.
I'll go to Antarctica and give it a
Wendell,
shot.
you're that close, okay?
Yeah.
Yeah.
If you go to Antarctica, let me know the time so I can ask NASA to turn off the military penguins, okay?
Yeah, it's fucking too cold for me anyway. Y'all ain't got to worry about me going there.
It is cold there, but luckily there's a bar at McMurdo Station, so...
Yeah.
Greg Ware... Yeah. Greg Ware, $2 Australian, says, finish this, Professor Phil. Aussie, Aussie, Aussie.
Aussie, Aussie, Aussie.
Oi, oi, oi. Brendan Casquetti, $10 Australian. Yes, don't forget kookaburras. No one can forget kookaburras. Design Song 1, $2. How do you balance your books? Maths or feelings, Wendell?
Feelings, man. You can't tell?
Right, the IRS does not need to know that, okay?
Right? Right? all by feelings.
So Wendell, if you want a kookaburra is a bird in Australian bird, and it laughs, literally laughs. So a good way to go out there and wake up the kookaburras is just shout flat Earth.
That was to make everybody laugh, eh?
All the kookaburras will come out.
I got you.
Golden Knight in the chat says FTFE, try saying cesium francoii thefki myoxyalalibium rixy dixy doxy drexy droxahide. There,
Yeah,
I think that was
up.
pretty good. Pat in the chat, sorry, for $10. Wendell, my man, if I'm ever in your town, I will stop by and grab some grub at your place and have a debate. Cheers, Craig.
Awesome,
I love calm
awesome.
debates. We need a Chernobyl level dumpster fire soon. Yeah, I was looking at some pictures on your Facebook, and it's making me like want some seafood. It looks yummy.
Right.
Pat in the chat, member for 8 months, says, 7 months of watching Flerfs being destroyed and educated. Here's to 7 more. Cheers, everyone. Many more, Pat. Thank you. Albeus UA, $5 Canadian says, you can see the movement if you look at the sky, Wendell.
You exactly right. I can see the movement of the things in the sky.
No. We've already established that they can't be up there, right? Like
Yeah.
that.
Simple.
Yeah, Golden Knight. I thought that might have been from Red Dwarf, actually. You're right. Donald Trump's Bone Spurs, who's been a member for 30 months, says, gotta lie to Flerf. Yeah, just ask Mitchell from Australia. He lies a lot. Edward J. Peters for $2. Rockets and space are gangster because of the G-force.
Awesome, man. Quick thinking.
So it's now known as the gangster force. I love it.
Right. That's awesome, man. G-force.
Albeus UA, $5
G-force.
Canadian says, hey Craig, pronounce... Fuck...
Shit.
Deoxyribon... I can do this one. Deoxyribonucleic acid. That's easy.
Oh, yeah. DNA, man.
Yeah, deoxyribonucleic
DNA,
acid.
man. We
Yeah, I
all
can
know
do
that one.
Hey, I learned that one at school. No ordinary plant. No, I'm not going to try and speak Welsh. Go away. The rabbit for $5 says, listen to what he's saying. Earth could be round, but I walk in a straight line. He's a Poe. No, the rabbit. I think you've misunderstood there. He's referring specifically to a Veritasium video about why gravity isn't a force, where he explains that if two people were at the equator at different points and they both walked directly north and never stopped walking directly north, even though they were walking in a straight line, if you were looking at it from an outside perspective on the globe, they would move together until they reached the North Pole. And that is... You can calculate a force in that because there's masses that appear to be accelerating, so there's a pseudo force that appears to be pushing them together. So no, he's not a Poe. He's actually explaining what Veritasium said quite well.
He did a good job.
Yeah. Terry Davis in the chat, another Australian, says, great show, shout out to Phil. Yes, and not absolutely shout out to Phil. That's going to be it for tonight, guys. Both of you, thank you very much. I know
Appreciate y'all, man.
It's very early for you, Phil, and it's very late for you, Wendell, so thank you very much.
Yeah.
Oh, the night's still young, man. I appreciate you guys. This was fun, man.
It was fun.
The long hair wants me to say bottle of water. Yeah, I've seen those TikToks, don't worry. Scotty McDongle 449 says, only just turned in. Did I miss any derpity derp? We're gonna have to go back and watch the whole thing to find out, won't you?
Watch it, brother.
Yeah.
Go watch it.
Thank you everyone for the massive support in the super chats. There was over 700 watching at one point, which is absolutely incredible. Thank you very much. I'm never going to charge for what I do, but obviously the super chats do massively help. Look out for a couple of videos coming up soon. One explaining the Kickstarter I'll be doing for the documentary about gravity. And new episodes of Flerfs Idiots, and another debate on Wednesday and another one on Thursday. So look forward to that, and remember, stupidity is not a right. Fight the flat earth.
Fight the flat. Fight the flat. Fight the flat. Fight the flat.
Yeah, Blue Marble, I will DM you very soon on Discord, dude.
Fight the flat. Fight the flat. Fight the flat. Fight the flat.
Thanks everyone for watching.
Fight the flat. 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 Fight the flat.
Right, good night, guys.